So in this video, we're going to revisit the idea of a sample space. Now, we've already done 2 examples of this. We looked at flipping a coin 1 time, and if we flip a coin once, then we end up with 2 options. You can either flip a heads, or you can flip a tails. So there are 2 things in our sample space there. If I flip a coin twice, then I could get a heads, 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 tails, tails, heads, or tails, tails. And I can see this because I end up with 4 different little branches, and I can find my options by tracing those branches out. Now if I go ahead and I flip my coin 1 more time, I'll go ahead and extend this one out. On each of these branches, I'll have an additional heads or tails option. The thing to notice here is if I do that, then when I go to list my options for flipping a coin 3 times, I would have a heads, 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 and so forth. And in total, if we count up all of our possible branches there, I actually end up with 8 options. And so to be clear here, when I flipped it once, I had 2 options. When I flipped it again, it was 4 options. When I flipped it 3 times, it's 8 options. And based on this, we can make a pretty good inference about what's going to happen next. That is, I'm willing to bet that if I asked you, what happens when I flip my coin 4 times, you'd probably say, okay, it's probably going to be 16 options. So that's for 4 flips, 16 total options with my branches. So the question is, like, what kind of pattern are we getting here? And I think it's pretty obvious that I went from 2 to 4 to 8 to 16. Each time I do this, it seems like I'm multiplying by 2, right? Question is, why are we multiplying by 2 first off? And the answer to that is, well, I'm flipping a coin. And so in reality, what's happening here is every time I flip it, I have 2 options. I have a heads or a tails. So here I have 2, 4, 8, 16. If I'm multiplying by 2 each time, this is kind of like taking 2 to a power. That is, over here I have 2 to the first power. Here I have 2 to the second power, 2 to the third power, and 2 to the fourth power. So we've already guessed that this 2 down here is because I have 2 options for each of them, which means we need to look at, well, why do I have that power up there? That is, why does this one to the first power, this one to the second power, that one to the third power, that one to the fourth power? And it turns out that's the number of flips I have. That is, over on this first one I flipped it once, had 2 options. Second one I flipped it twice and had 4. Then when I extended my tree out, I flipped it 3 times and had 8 options. When I flip it 4 times, I have 16. And so what we've deduced here is kind of a formula. And that is, if I have, for n flips of a coin, I will have 2 to the n outcomes in our sample space. And once again, this is coming from the fact that, okay, when I flip a coin, I've got 2 options. And then each time I flip it, I'm going to multiply it by 2 again, so 2 to the nth power. So, for instance, if I flipped a coin 10 times, I'd have 2 to the 10th power number of options in my sample space.